Hi everyone, this lesson is for geometry CPM students. This is chapter 3 test review on similarity. So let's get started. Our first thing is we have a lot of learning targets for this chapter. Make sure that you've gone through all of the learning targets and that you do understand. And if there's some confusion on that, make sure that you review your notes, look at the class notes, look at the review videos, as well as, redo some of the problems that might help you gain some understanding for that problem or that topic. Below is a list of vocabulary words used in this chapter. So make sure that you go through these words and that you can identify what they are and you can define them because they are all from this chapter. You all see something like that on the test. So we're going to start with a warm-up, and for this problem we are going to find x and y. So what I'm seeing is that these two triangles automatically are similar, and the reason for these two triangles being similar is because of these parallel lines. And what happens when you have parallel lines is you have corresponding angles that are congruent. So you've got that angle here is going to be congruent to that angle, as well as this angle here congruent to this angle here. And similarly, good word for this chapter, this triangle at the top is going to be congruent to itself because when I split up these two triangles, they're the same angle. So I'm going to take this triangle right here and I'm going to redraw it over here. And the second triangle, I'm going to redraw and then put it over onto the other side. So we're going to take this and move it over here and then put in the information that is necessary. So for example, this is 9 and this is 12 and this is unknown, that's x. And we also know that the left side here is 12, 9 plus 3. The base is 8. And the right-hand side right here is you're going to add these two sides together. So that's going to be a y plus 12. So additionally, we know that this angle here is congruent to this angle. We know because of corresponding angles. And we know that these two angles down here are also congruent. And along with the top, those two angles are congruent as well. These two shapes are congruent by what we call angle-angle similarity postulate. Because if you have two angles that are congruent in a triangle, then the third one is automatically congruent if you didn't know that. So let's make a proportion to find x. But before I do that, I'm going to start off with my scale factor. And my scale factor compares the same corresponding side in different triangles. So the only two, I don't have x, so I can't correspond with 8. I don't have y, so I can't correspond with these two. But I do have 9 and 12. So we have 9 is to 12. And so what that is going to tell us is that reducing that by 3, I'm going to get 3 over 4. So my scale factor is 3/4. So I'm going to use that to find the other lengths in the triangle. So to find x, I'm going to go 3 is to 4, which is my 9 is to 12. So left side is to right side as left side is to right side. As x is to 8, I'm going to cross multiply. I get 4x is equal to 3 times 8, which is 24. I'm going to divide by 4, and I get x is equal to 6. Put that in a solution set because that is a solution. Additionally, we are going to use that same scale factor to find y. So we're going to go 3 is to 4. You're going 9 is to 12. And of course, I could go 6 is to 8. I'm still going to get 3/4. As 12, this 12, is to y plus 12, which is this side. Left side is to right side. I'm going to cross multiply. I'm going to get 3 times y plus 12 is equal to 12 times 4. And these numbers aren't huge numbers, but just a note, if you want to reduce these, you can, because I'm going to divide by 3 on both sides. And in doing that, I'm going to reduce the number so that it's not such a high number that I'm dividing and multiplying and adding and etc. So I have y plus 12 is equal to 3 divides into 12, 4 times 4 times 4 is 16. I'm going to subtract 12. So I get y is equal to 4. Put that in solution sets. That's a solution. So y is 4. So that means this whole length here is 4 plus 12, which is 16. And I would want to know that because if I wanted to find, let's say, the ratio of perimeters, then that I could add all the perimeter up, right? I could go 9 plus 12 plus 6 to 12 plus 16 16 plus 8. Or I can take my scale factor because my ratio of perimeter is equal to my scale factor. They're the same value. So I know that the ratio of perimeter is 3 to 4. Additionally, if I wanted to find the ratio of areas, in order to find the ratio of areas, I would need to find the area of both of these triangles, right? Which is, I'm going to use 1/2 base times height, but the base would have to be perpendicular to the height, which it's not necessarily here. So that would be a little bit tricky to find. However, we do know how to find the ratio of areas because the ratio of areas is my scale factor squared, is my scale factor squared. So whatever my scale factor is, which is, it is 3/4, I'm going to square that, and that's going to be 9/16. So that's my ratio of areas. For this problem here, so additionally, that was a great warm-up. That really had a lot of the topics from the chapter in it. As for this chapter test, you also are going to have problems that you've seen in previous chapters, like from chapters 1 and 2, because we replace one of your test scores. If you wanted chapter 2 to be replaced, I could replace it with chapter 3 because I'm also testing on some of those concepts. So we do have that. So that means that you will see problems from chapters 1 and 2 on there. So I'm going to take the first, 5 or 10 minutes here, and we're going to review these chapters, the previous chapters, and make sure you're all on board for that. This question says vertical angles or this question says rewrite the statement as a conditional. A conditional is going to include statements with if, then. So that's a conditional. If you do this, then this will happen. And so we have the first statement says vertical angles are congruent. So you want to say if two angles are vertical angles, then the angles are congruent. And so that's an if-then statement. We got our hypothesis and our conclusion. Complementary angles have a sum of 90 degrees. So you would say if two angles have a sum, and you could flip that, right, of 90 degrees, then they are complementary angles. And you also, for this statement, can do the converse of that, right? You could say if two angles are complementary angles, then they have a sum of 90 degrees. But if you were to take the converse of the first problem that says vertical angles are congruent, if two angles are vertical angles, then their angles are congruent, and you said if two angles are congruent, then the angles are vertical angles, that's not necessarily true. So sometimes when you flip them, right, and take the converse, it's not always true. This problem is saying a midpoint divides a line segment into two equal parts. If M, you could say it like this, is the midpoint of a line segment. You can even give it a name, A, B. And then if M is the midpoint of a line segment, A, B, then the midpoint divides the segment into two equal parts. And you could say, you can even draw a diagram, right? If you were explaining this, here's AB, you could put in a midpoint like this, and then therefore you would say AM is congruent to line segment MB. And then that would be a great explanation. Definitely, if you're asked to explain something like this, have a diagram and show that, prove that, okay? Because there will be some fill in the blanks. For this problem here, your job is to find the missing variables. So a couple of things that you can do. Number one, I see two variables. I have an A and I have a B. So, and I have a B over here. So you may have to have two different equations. What I see right away is that this line, right, this is a line, and that adds up to be 180 degrees. So meaning I can say right off the bat, 3b plus 5b plus 28 is equal to 180 degrees. And yes, I'm going to get my calculator out here. I have 5b plus 3b is 8b. And I have, so that's plus 28 equals 180. So I'm going to go 180 subtract 28, and I get 152. Okay, and that equals 8b. So that means divide by 8. So I'm going to take that value and divide by 8, and I get 19. So b is equal to 19. Put that in solution sets. That's an answer. That's a solution. Okay. So b is 19. So now I know that b is 19. So actually now I can say that 3 times 19 is 57. So this angle here, which is 3b, is actually 57. And so I know that 57 plus 26 plus a is equal to 180. So 57 plus 26 equals 83. And so I've got 83 plus a equals 180. I'm going to subtract 180 minus 83. I'm going to move that 83 to the other side, and I get 97. So that a is equal to 97 degrees. Solution set. Okay. All right, right on. Moving on. Review for area. Area is 1/2 base times height. That's the area formula. Where, because there's a stipulation, the base is perpendicular to the height. If your base is not perpendicular to your height, you cannot find the area. So, yeah. So we have my base is here, my height is here. All right. Because now see how they're perpendicular? It says that the area of the triangle ABC is equal to 36 centimeters squared. And what is the length of AB? I'm going to assume that we're giving AB, this is AB, I'm going to call it X. And we weren't given a value. So I'm going to say given that AC is 4. Okay. And we're going to call that 4 centimeters. So given this information, because you can only have one unknown. All right. So we know that the area is equal to 1/2 the base times the height. And so I know the area is 36. So I can put that in here. 1/2. I don't know my base, so I'm going to leave that alone. But I do know my height, which is 4. So my base is still unknown. But I can do 1/2 of 4 is 2. So I have 2b is equal to 36. So b is equal to 36 divided by 2, which is 18. So I know that b, being my base, is now 18. All right. And that's going to be centimeters. But the question said, what's the length of AB, which is this length here? So with this information, now I'm going to have to use the Pythagorean theorem in order to find this third side. So I'm going to go 4 squared plus 18 squared is equal to x squared. And I know that 4 squared is 16. And I know that 18 squared is 324. So I'm going to go 16 plus 324 is equal to x squared. And I'm going to add those two, 324 and 16, and get 340 is equal to x squared. And to undo this x, right, the squared, that value, remember, you know that the square root is a 1. It's a 1/2 power. And so if I were to take square root both sides, right, if I were to square root both sides, what is actually happening is I'm going x squared to the 1/2 power where the 2's cancel. So I get x, and then the square root of 340 is going to reduce down to 2 root 85, and then that's what x is. The way I did that was on my calculator, but if you don't have a calculator that will reduce that, what you would need to do is start off by just reducing like this. And so that's 10 times 34. 34 is 17 times 2. 10 is 2 times 5. And then see, I've got 2 times 2, which is 4, right? So root 340 technically breaks down to root 4 times root 17 times 5, which is 85. And then the square root of 4 is 2, so we have 2 root 85. And yeah, this calculator is amazing, and this is the one that I would get if you have a chance to do that. They're a little pricey, but actually I'm PTSA, thank you, Mountain View PTSA, gave us some calculators, and if you need one, you can ask me, email me, and I can get one for you to use. Okay. All right. Parallel lines find all the angles in the given diagram. So you have 2 parallel lines. What your job is to do is to go all the way around. I'm going to start off. If I have parallel lines, I know that these angles here inside, right here and here, those are called supplementary. Those are supplementary because they're same side interior angles. So what that means is I'm just going to call this, I don't know for right now, and say 41 plus x plus 93, we know is going to equal 180 degrees. So I'm going to take those values, 93 and 41, and I'm going to move them on the other side of my equation. So I'm going to go 180, I'm going to subtract 93, I'm going to subtract 41, and I get 46. So I've got x is equal to 46. So this angle right in here is 46. So now I'm going to put that there. And a couple of things are going to happen. These are vertical angles here. 41, this is 41 here. And we know this is 93. 180 minus 93 is 87. So that means that's 87. That's 87. Similarly, 180, right, minus 87 should be also, what did I get? 93. Yeah, very good. 93. And this angle here and this angle here are corresponding angles. They have to be congruent. This angle is 93. We got all these around. In order to find this angle down here, I see this triangle. This is happening here. And so a triangle has a sum of 180 degrees, right? So 180 minus 93 minus 46 should be 41. And then again, these angles are alternate interior angles also. 41 degrees here, and 180, let's see, hold on, 180 subtract 41 should be 139, so that's 139, and that's 139. I think we hit all the angles. All right. For this review problem, finding the perimeter of the figure, you are going to have to find, so this is a little bit tricky for sure, you need to find all the lengths to find the perimeter. And so for these ones right here, some of these are a little bit easier. For example, this length here, you need to know these points, right? So this is 1, 2, 3, 4, 5, 6, 7. So this is 7, 1, 2, 3, 4. So that's 7, 4. All right. This point over here is -8, 4. This point, 1, 2, 1, 2. So this is -2, -2. And this point is 1, 2, 3, 4, 5, -2. All right, so 2 things. The horizontal ones are super simple. The horizontal ones are like this. You've got, let's see, 1, 2, 3, 4, 5, 6, 7. 5 minus -2 is 7. This is just a distance, right? 5 minus -2 makes 5 plus 2, which is 7, because distances are always positive. That's why I use the absolute value. So we know that this length right here is 7. All right, absolute value 7 is 7. We also know that if this is -8, that distance is positive. That's why you have the absolute value. So this is going to be 8 on this side and 7 on this side. So 8 plus 7 is 15. So this length here is 15 here. So far for my perimeter, I have 15. Okay, so far for my perimeter, I'm going to put P is equal to 15 plus 7 plus. And now for these sides here, you know, you can use a variety of things. Number one, you can use Pythagorean theorem, or you can use your distance formula. In case you forgot your distance formula, it's subtract your x's, square that value, plus subtract your y's and square that value. Whoops. And so in order to do that, subtract my y's, right? Minus y1, and then square that value, right? You would go 7 minus negative 5, or excuse me, 7 minus 5, and then square that. So let's just do it. So we have the square root of, I'm going to make more room here, 7, subtracting your x's, 7 minus 5, square that, plus 4 minus negative 2, square that. And so these two will make plus 7 minus 5 is 2. 2 squared is 4. So that's under the root, plus 4 plus 2 is 6. 6 squared is 36. So this length is the square root of 40. I can reduce that to take out a 4, right? Square root of 4 times square root of 10. So that's going to be 2 root 10. So this length is 2 root 10. Now to find this length, I can also use my distance formula, but I'm actually going to show you a different way, and I'm going to use Pythagorean theorem. And so that means if I went up 4, this is 4 and this is 2, so this length is 6. And for this value here, this is negative 2 to negative 8, negative 2 to negative 8, that's also 6. So 6, remember this, 6 root 2, use Pythagorean theorem. And so that length is 6 root 2. So for my perimeter, it's going to be 15, this length. Let me highlight this. It's going to be 15 plus 2 root 10 plus 7 plus 6 root 2. All right, so let's write that out. And doing that, 15 plus 7 plus 2 root 10 plus 6 root 2. And remember, you can only combine numbers that are exactly the same. So my perimeter is going to be 15 plus 7, right, which is 22, add 2 root 10, add 6 root 2. And then that's my perimeter. And this is, we didn't state the units, so you would just say perimeter is always in units. So I'm just going to say units. For this, now back to our actual chapter, right? Your job is to find the missing variables. So this is from chapter 3. The other stuff was review. Find the value of the missing variables. So it looks like we have 2 variables here. So it does say that these are similar. And I'm going to redraw them because right off the bat, it's always important that you take your similarity statement and you redraw them. And by the way, these are similar because of angle similarity, because vertical angles and this angle down here that are congruent. All right, so it says FGH. So see how they start with F and they go up G over H. So that's this triangle here. So we have F, G, and then H. That's X, Y, and 4. Okay, so now that's similar to GKH. Now, see how I wrote F starting here, F, and then went up G and over H? That's how I have to write this next statement. And right now, I'm not even looking at this. Don't look at that. I want you to look at this because F has to correspond with J. G has to correspond with K. Okay, so that's how you have to write it. You have to think like that. Okay, so you're going to redraw this triangle. And so J is first because F and J have to be congruent. And then G has to be congruent with K, and H is the same angle, right? Okay, because it's in the middle here. That's the same value. So now I'm going to erase this so that I can figure out what the sides are. All right, so I know that HJ is 5, HJ, so that's 5. HK is 3, and KJ is 8. So I need a scale factor to start off. I know this is 4. And remember, when you're comparing, and I'm done with this, just cross it out because you don't want to look at that anymore because now what you've done is what you have are your new shapes and you've written them the right way. And so let's see, our scale factor, which is important to know, is 4 to 5 because you're comparing this side with this side, okay? And those are corresponding sides. So now to find X, I'm going to go 4 is to 5 as left side is to right side, X is to 8. As X is to 8. I'm going to cross multiply. I get 5X equals 32, and I get x equals, because I'm going to divide, and it's completely fine to get a decimal, okay? So you're going to get 32 divided by 5, and I'm going to get 6.4. So this is 6.4. This is an equation. Put in solution sets. If you are a box person and you're like, wait, I want to put my answers in boxes, you don't put 6.4 in a box. 6.4 goes in a solution set because it's the answer to a solution. You can box the whole shape if that makes you happy, okay? Next problem, we want to find y. So again, I'm going to use my scale factor, which is 4 to 5, as y is to 3. I'm going to cross multiply. I get 5y is equal to 4 times 3, which is 12. I'm going to divide by 5. I get y equals 12 divided by 5, right? So 12 divided by 5, you guys, is just what? 2.4. So this equals 2.4, and this is a solution. Again, let's see, 2.4, and put your answer in solution set. For these problems here, it says each pair of figures below is similar. So they're telling you, yes, they're similar. You don't have to prove that. Find the lengths of the unknown side. They are marked with a variable. So looks like we have a W. So to find this W, that's going to correspond with that 6. So I'm going to go 6 is to W, because that's what I want to find first. And now I have to find two sides that I have. I can either say 3 is to 4, or I could say 11.25 is to 15. That's your choice. I'm just going to go 3 is to 4 and cross multiply. We get 3W equals 6 times 4, which is 24. I'm going to divide by 3. I get W is equal to 8. In order to find Y, which is right here, I'm going to use the same scale factor, which is 3 to 4. And I'm going to say 3 is to 4 as Y is to 7. So we're going to cross multiply. We get 4Y equals 21, and Y equals 21 divided by 4, and 21 divided by 4, and that's going to be, what, 5 1/4 or something. So that's 5.25, or 5 1/4. You can write that out like that, and you're done with that problem. On the right side here, we already know these are similar. So you just have to set up your equations. So it looks like I'm going to use 9 is to 15 as my scale factor. So 9 is to 15, and I'm going to reduce that. That's my scale factor. I'm going to reduce that to 3, divide by 3. I'm going to get 3 over 5. So I'm going to say 3 is to 5 as, and I'm going to find x first. So 9 is to 15, which is 3 is to 5, as 6 is to x. So 6 is to x. Cross multiply. I get 3x equals 30, and I get x equals 10. Solution set. X is done. To find z for this problem, I do the same thing. I go 9 is to 15, which we already know is 3 is to 5, as z is to 12. So cross multiply. I get 5z equals 3 times 12. 3 times 12 is 36. I'm going to divide both sides by 5. I get 36 over 5, which, by the way, you can leave it like that. Or you can make it into a decimal, which is 7.2, and you're done. For these two problems here, you have to find x. And I see that there are parallel lines. We know that these are similar from our warm-up problem, remember. I personally like to separate the triangles. I know some people will go make a proportion like this. Let's do both, and just to show what that gives us. Like if I did 33 is to x as 27 is to 18. If we cross multiply, I get 27x equals 18 times 33. And so x equals, I'm going to go on my calculator, I'm going to say 18 times 33. That equals 594. I'm going to divide by 27, and I get 22. So x is equal to 22. All right. Now, yes, that was super fast. For me, though, I like to split up my triangles. And I'm going to go, for me, I'm going to say 33, the little side, 33 is to the long side, which is x plus 33, as the little side, 27, is to the sum, which is 27 plus 18, and 27 plus 18 is 45. I'm going to cross multiply, and getting these two to cross multiply, that's going to give me 33 times 45 is equal to 27 times x plus 33. I'm going to distribute. Actually, I'm going to divide by 27 first. So I'm going to go 33 times 45, and that equals 1485. And I'm going to take that 1485 and divide by 27. Okay, divide that by 27. And I get 55. And so I have 55 equals x plus 33. I'm going to subtract 33, and I get x is equal to 22 again. So I understand that the way I did that was a little bit longer. I just prefer doing it that way. So you can choose. For this one right here, though, I also can do that, and I could be smart like that, and I can say, if I know that this whole length is 27, right? 27 subtract 15 is just 12, so I know this is 12. So realistically, I can say this side 15 is to 12 as 20 is to x. I can cross multiply. I can go 15x is equal to 12 times 20. If you don't have a calculator, I mean, there are ways around that, right? You can just cancel and say, well, 15, rewrite that. It's 3 times 5. 3 divides into 12 4 times. 5 divides into 20 4 times. 4 times 4 is 16. Solution set. Answer. For this problem here, we know KR, it's telling me KR is to RT as KS is to SU. All right? So they're telling you that. They want you to use this proportion. We know that KR, given the information, KR is 12, RT is 9, KS is 16, and they want to find KT. Well, we know KT. KT is just 12 plus 9. Well, that's 21. They also want to find SU. So let's find that next. And so we would go 12 is to 9 as 16 is to x. Cross multiply. 12x equals 9 times 16. 9 times 16 is 144. And that equals 12x. And dividing by 12, I get x equals 12. 144 divided by 12 is 12. Now, so that's SU. So SU is 12. Okay, SU, where's that? So I'm going to cross that out. We just found that. That's 12. Now they want to know what KU is. Where's KU? KU is this whole length. Well, it's just 28. You just have to add 16 plus 12. For these two problems here, oh, there's a problem. It says, what is wrong with the given triangles below? Look for contradictions between what's true and what should be based on facts. So we know that if these two triangles are similar, if you have two triangles similar by angle similarity, which it kind of looks like, but not really, right? Then what that means is all the angles are congruent. This angle is congruent to this angle. This angle is congruent to this angle. And this angle here, this angle has to be congruent to this angle. But it's not. So these two triangles can't be similar because 63 degrees does not equal 86 degrees. So the reason is because those angles should be congruent if the two triangles are similar, therefore they're not similar. And then a contradiction is it looks like if you have two angles, right, that are congruent, then it should be by angle similarity, but it's not because they're not congruent. So that's the contradiction. For these two problems here, it says what's wrong with these two triangles. Well, we have sides that could or maybe be proportional, right? Meaning 5 is to 10 as 3 is to 9. If I cross multiply, I get 30 equals 45, but that's not the case. They don't equal. So these are not similar. And the contradiction is that if you have side, angle, side, right? Side, angle, side. Normally, these two triangles would be similar by side, angle, side similarity theorem. However, because they're not, the sides have to be proportional. So even if you have the angles that are congruent, it's not automatically, the two triangles are not automatically similar by side angle side unless the sides are proportional. But because the sides aren't proportional, the two triangles are not similar. That's the contradiction. So we have quadrilateral, that's a four-sided shape, JUMP, so J-U-M-P, and it's similar to, it's telling me it's similar. So what that means is that all my angles are going to match up. And that means if something is similar, two things happen, right? The angles, all angles are congruent. Second thing, number two, sides, all sides are proportional. Okay, so no matter what, if you know that the two shapes are similar, the angles have to match up and all the sides have to be proportional. That is a rule, that is given, that is going to happen. So in doing that, that means that this angle here, that's V, because they're all lined up, O-V-E-R. Notice how they went J up U, down M. O up V, down E. So they're completely lined up, and that's what you need to make sure. And so 70 is here, and I know that's 90. That has to be 120 degrees, and that has to be 80, because all the angles have to match up. Okay, so additionally, the sides have to be proportional. So I need to find little a. So in order to find little a first, I need two sides that I can compare to find the scale factor. And the only two sides that I have are 21 and 9. So I'm going to say my scale factor is 21 over 9, but I need to reduce that by 3 because it's going large to small. So reducing that by 3, I get 7 is to 3. So my scale factor is 7 over 3. And even before I know the perimeters, I also know my ratio of perimeters, right? My ratio of perimeters is going to be the same thing as my scale factor, which is 7 over 3. But my ratio of areas is going to be my scale factor, 7/3 squared. 7/3 quantity squared. So that's going to equal 49 over 9. In case you get asked that on the test, which you will. Okay. All right. To find A, we are going to use our scale factor, 7/3. So I'm going to go 7 is to 3. So I'm going 21 is to 9. That's 7 is to 3. Where's A? As A is to 6. As A is to 6. So I'm going to cross multiply. 3 times A equals 7 times 6. And I know 3 divides into 6, so I'm just going to divide by 3 right now. 3 divided into 6 is 2. 2 times 7 is 14. So A, solution set, is 14. So A, solution set, is 14. Oops, I put A in there. So let me rewrite that. Okay, so that's 14. Yeah. Okay, so now let's find B. B is there. Okay, so let me erase this a little bit so I can see B. B is right there. So we're going to say 7 is to B. So you're going to go 7 is to B as scale factor. 7 is to 3. B has to be 3. Cross 3, right? 7 times 3 is 21. So these are equal. These are equal. B is 3. Solution set 3. And C, 14. So we're going to go 21 is to 9, which is 7 is to 3. So 7 is to 3 as 14 is to C. 2, multiply by 2. Here, 7 times 2 is 14, so 3 times 2 is 6. So C has to be 6. And if that confused you, because all I did was set up this. I had 7 over 3 equals 14 over C. Yes, I can cross multiply. I can say 7 times C equals 3 times 14. Divide by 7. C equals 3 times 14 divided by 7. 7 divides into 14 twice. 3 times 2 is 6. Okay, but what I did as a little kind of shortcut was I said 7 times, because these are equal, right? Equations are equal. So that means this has to equal this. So 7, how did I get there? I times 2. So that means times 2 here. 3 times 2 is 6, and that's how I got 6. And then these other angles here, we already filled in the angles, so you could just fill those in. 2 similar polygons are shown. Find the values of x, y, and z. The thing with this is that these are flipped, right? I'm going to see how this is congruent to that. I'm just going to redraw these because I want to make sure they're lined up. So this right here goes down over higher and then down like that. Okay, so that I know that this angle 15 is this angle down here. We're by the 15. And then my base is still Z, but this height here is 20. This up here is X, this here is Y, and this angle here is equal now to that. So I'm going to go like that because I don't want to look at that anymore. So to find X first, I need my scale factor. My scale factor is 15 over 20, which is going to divide by 5 on both ends. So I'm going to go 3 over 4. So my scale factor is 3/4. The reason I have a scale factor is now I can just set all the other ratios equal to it to have a proportion. So I'm going to go 3:4, which is left side, right? As top is to top, as 21 is to x. So I'm going to cross multiply. 3x is equal to 4 times 21. X is equal to 4 times 21 divided by 3. 3 goes into 21 7 times. 7 times 4 is 28. So I have x. Now to find y, I do the same thing, but I'm going to use the heights, right? So I'm going to say again, 3:4 as, and now I have 18 is to y. So 18 is to y. I'm going to cross multiply. I get 3y is equal to 4 times 18. Y is equal to 4 times 18 divided by 3. 3 divides into 18 6 times. 6 times 4 is 24. So there you are. And so you have x, y. Oh, am I missing z? I am. So again, 3:4 as z. So I want 27 is to z. I'm going to cross multiply. I get 3z and it is equal to 4 times 27. And again, 3 times what is 27? So 3 times 9. So that means 4 times 9 is z. So z must be 36, right? Different ways you can do that for sure. For this problem, it says 2 triangles are similar and, oh no, 2 triangles are shown. Are they similar? Explain why they are or aren't similar. If they are similar, find x. Yes, they're similar because these lines here are parallel, because they're in the same shape. They have to be parallel. We know that we can say, and then just doing this, we can say 40 is to x. We've got the angles that are congruent like that. We have this angle congruent to that angle there. We have this angle equal to itself. These 2 triangles are congruent by angle-angle similarity. I'm going to go 40 is to x as 50 is to x plus 2. Cross multiply, I get 50x equals 40 times x plus 2. I'm trying to isolate the x eventually, so that means I'm going to divide both sides by 50. And even before then, I mean, actually, I'm not going to divide by that yet because I do want to distribute first. And so in distributing 40 times x, so that's going to be 40x plus 40 times 2, which is 80. And that equals 50x. So now I'm going to move the x over here. I'm going to subtract 40x from both sides. And in doing that, I get 10x equals 80. Divide by 10, x is equal to 8. Done. Are these 2 triangles similar? If they were similar, they would be similar by side angle side similarity. But that would mean that the angles would have to be the same. Check, they're both 90. So that's true. And it also means that my sides are proportional. So let's check. 8 is to 8. See, this looks like it's tilted, doesn't it? So I'm going to fix that. And I'm going to make this 8 here and 14 here. So we have 8 is to 8. Oh, that's a ratio. That's a scale factor or a ratio of 1. If my scale factor or common ratio is 1, that means ... That means therefore, by the way. That means that my 2 triangles are congruent. That's what that means. If my scale factor is 1 when I compare the 2 sides, 8 is to 8 as 14 is to 14. If that's the case, right, 14 is to 14, I also get 1. That means that the 2 triangles are similar. So if you're asked, what does it mean if the ratio, right, is 1 to 1? Because if you divide 8 divided by 8, you get 1 over 1. And again, remember all the different ways we can write a ratio is 1 to 1. You can say 1 to 1. or you can say 1 over 1. So if my scale factor is 1 to 1, that means that the two triangles are congruent. Don't forget that. Okay, for this problem here, it says in order to estimate the height of a tree, in order to estimate the height h of a tall pine tree, a student places a mirror on the ground and stands where he or she can see the top of the tree as shown. Well, as shown, I didn't draw that yet. So I actually want you to try to draw this. The student is 6 feet tall. So, I mean, like, let's just say student's tall, here's the tree, and there's a mirror in here somewhere. It says, and stands 3 feet from the mirror, which is 11 feet from the base of the tree. So I need you to try to draw this because you're going to need to draw this on the test. So you've got a person that's 6 feet tall, right? You've got a pine tree. Oh, we don't know the height. We're going to call that H. And you know you're 3 feet from the mirror, which is 11 feet from the base of the tree. They want to know the height, or they just, first of all, you're just going to draw the diagram, right? So this has got to be like a reflection. Okay, and so that's what I get when you draw, and I draw that. I hope you got something similar. This also, I drew it like this, a little flipped, but that's totally fine. And so you've got 3, and then you've got 11, and you've got your height. So your job is to find the height of the tree. These two triangles are going to be similar, and that you see how you've got your angles. Look at your angles, because you've got to show that the angles are congruent, right? Height and base are perpendicular. So here's one angle at least that's congruent, right? Similarly, these are parallel. So if these are parallel, it also means that I have alternate interior angles and etc. So we also have 2 other angles corresponding, etc., that are congruent. So these have to be similar. So now, how do I find the height of the tree? Okay, so what I know is that I can go 6, and your choice. You can go you can go large to small, small to large, right? We're going to go 6 base is to base. So we're going to go small, large. 6 is to H. So 6 is to H as small. 3 is to 11. We're going to cross multiply. We get 3H is equal to 11 times 6. And I'm going to divide by 3 for my height. So I get my height equals to 3 divides into 6 twice. 11 times 2 is 22, and this is feet. And that's my answer. Okay, cool. A 40-foot flagpole cast. We're going to, again, the part of this is that you have to visualize what's actually happening. So yes, you need to draw these. And so you also need to not be afraid to make mistakes in drawings and reset it. So here's my flag, and here's my flagpole, okay? It says my 40-foot flagpole, so there's 40 feet, cast a 25-foot shadow. You guys, you need to remember, unless you're Peter Pan, right, your shadows are always on the ground. So here's the shadow. I've got 25-foot shadow. And actually, it does look like my shadow is longer than the 40-foot pole, so I'm going to erase that a little bit, right, to make it more realistic. All right, so now we've got a 20-foot shadow, 25-foot shadow. It says, find the shadow cast by a nearby building that's 200 feet tall. So now I've got another building. I got some building way up here, right? I'm going to make this a building block. And so now I basically am going to create another similar triangle, right? Like this, because I would need this little cool mirror down here to reflect that and give me congruent angles. And so in doing that, we know these are right. And the shadow, this is 200. So now I need the shadow cast. And so in doing that, now we're going to create a proportion, right? And I'm going to go, and you can redraw these for sure. Like I could redraw this because I like doing that actually. 200, and this is unknown. So I can say 40 is to 200 as 25 is to x. So 25 is to x. I'm going to cross multiply. I get 40 times x equals 25 times 200. I'm going to divide both sides by 40. And in doing that, I get x equals, 4 divides into 25 times, 5 quarters, 125. So this looks like I'm in feet. So this distance, this shadow, is 125 feet. Okay, cool. So I go to Lake Sabrina in North Lake. These are campgrounds. So I thought it would be appropriate to show you something like this. Campsites Lake Sabrina and North Lake are on opposite sides of the lake. And so we've got two sides. It says a survey crew made this very cool measurement, which these are not the opposite sides here. It's here is an opposite side and here. So let me see if I could use this and this. This is the length. So I want this length right here. So to find x, that's x. X marks the spot. Okay, so to find that value, okay, I'm going to make a proportion. So I'm going to go small to large. So a couple of things. Number one, we also know this is congruent to this. Okay, those are vertical angles. They did say that they were similar, and meaning this angle up here is congruent to this angle down here. And so therefore, I've got the angle-angle similarity postulate that I can use because those are congruent. Only because they're congruent. Because otherwise, if those angles are incongruent, you can't assume that they are. We've got the two angles inside here. We've got this angle congruent to this angle, and we've got this angle congruent to this angle here. So now I've got my two angles. So now making a proportion. I'm going to say small is to large. Small is to large. So I'm going to go x is to 345.6 as. Now, this is the trick here. Do I use this or do I use this to compare to 452? All right. So we've got small is to large. So this is going to be 452 meters. And so what you need to understand is this here is flipped, because see how this angle is congruent to this angle in the right-hand corner? That means that I have to use, if I'm using 452, that I have to use 361. So 361.6. Now I'm going to cross multiply. Yes, I'm going to use my calculator. 452 times x, okay, is equal to 361.6 times 345.6. So let's do that, okay? And so we have 361.6 times 345.6 is equal to a big number. Take that number and divide that by 452, and I get x is equal to 276.48 and meters. And that's how far the two campgrounds are apart. This is one campground. This is one campground. That's how far the two campgrounds are apart. So that concludes the review. I wish you the best of luck on your Chapter 3 test, and make sure that you complete the worksheet. That is the study guide for tonight, as well as on Wednesday, complete the Last Minute Lucy study review as well. All right, good luck. Thanks for watching.